All right, in section 5.5, we're going to begin logarithmic and exponential functions. And the first thing I want to do is go ahead and define what a logarithmic function is. So if a is a positive real number and a cannot equal 1, and x is any positive real number, then the logarithmic function to the base a is denoted by log base a and is defined as log base a. Now you can change this into an ln. And most of the time what we'll do is we'll actually just write it ln x over ln a. So you take ln of the x over the ln of a. And that will allow you to change any log function into an ln. Another couple things we need to realize in this unit is the derivative of exponential functions. We'll have to memorize this. The derivative of the exponential function is ln of a, and then the exponential part. The ln, or the derivative of a to the u, that's when you have anything other than an x, is that a to the u, the derivative of that exponent, and then the ln of a. The derivative of log base a of x is 1 over ln of a x, and the derivative of log base a of u is 1 over ln of a u with the derivative of that u. We'll refer back to those as we do derivatives. Here at first, what we're going to do is remember what logs really look like and how we solve for them. So I'm asked to evaluate this without an expression, or without a calculator. So what we're really doing is saying, what does this equal? Well, the way logs work is this is the base of the exponent. So we've got base, this is the exponent, so we have base to the exponent equals 9. Now, how can I make this, or how can I solve this without using a calculator? Well, what I need to do is I need to put these as bases, or equal bases on both sides. So I've got, this would be really 3 to the third power to the x power, and this would be 3 to the second power. So I have 3 to the 3x, and I have 3 to the second. So that really means I can cross out my bases and just solve this simple equation. 3x equals 2, and I get the answer as x equals 2/3. Let's look at a couple more of those. I'm not actually asked to evaluate without a calculator. I'm just asked to write it in exponential, write the exponential equation as logarithmic or vice versa. So if it is in log form, we're going to write it in exponential form, which is this form. If it's in exponential form, we're going to write it into log form, just going back and forth between the two different equations. So this is my base, 3. This is my exponent, -2. And then this is what it equals. This is a very true statement. 3 to the -2 is 1 over 3 squared, which is 1/9. On the next part here, we're supposed to write it as a logarithmic equation because it's in exponential form. So I'm going to say log, my base is 49. The answer is 7, equals the exponent part, 1/2. This next problem, I'm asked to sketch the graph by hand. The way we're going to sketch this graph by hand is just making a t-chart. So I'll just pick some random values like -2, -1, 0, 1, and 2 and see where that gets me. So when I plug in -2 into this, I have 2 to the -2 squared. Well, -2 squared would be 4, so 2 to the 4th power is 16. Put in now 2 to the -1 to the 2nd. That would make it a +1, so that would give me 2. Put in 0. Anything to the 0 power is 1. Put in 1, I end up with the same answer, 2, and then 16. And then I could just sketch this graph. Not a very pretty graph, but I did get it accomplished. I've got 0, 1. I've got 1, 2, -1, 2, 2, 16, and -2, 16. Alright, for these next problems, we're either going to solve for the x or the b, whatever is in the problem. So the first one here, what I have is I have it in log form. I don't want to figure it out in log form, so I'm going to say the base is 3, the exponent is x, and then I have 1 over 81. So I'm going to go ahead and figure this out in terms of exponent of, or base of 3. So this would be 1 over 3 to the fourth. So this would be 3 to the x equals 3 to the negative fourth. So that means that x is equal to negative 4 for this problem. The next one here, I'll keep my base of 2. I'll write my exponent of negative 4 equals the x. So x is already by itself. I just need to figure out what this is. 1 over 2 to the fourth is 1 over 16. On the next problem, I have the base is b to the third power is 125. So I'm really asking myself, the cube root of b to the third is equal to the cube root of 125. So I have b is equal to 5. This last problem is actually written backwards, but here's my base. The base is 5. The exponent is x squared minus x, and that equals the 25. So I have 5 to the x squared minus x equals 5 to the second power. So I can cancel those parts out, and I have x squared minus x is equal to 2. I can solve this quadratic by factoring. So I'm going to squeeze this in right here. X minus 2, x plus 1 is how that factors. So that means my answers would be 2 and negative 1. Going on to some other problems here. This says to solve these to 3 decimal places, so we'll go ahead and use our calculators in order to do that. What we have is we have the x and the exponents, and so we're going to have to use log or ln's to be able to figure out these. So I'm going to use the log properties by ln'ing both sides, or the natural log properties. Now I'm going to use the property where I can bring the exponent out front. And then I'm going to get the x by itself. So I'm going to divide by 6 ln 5 on both sides. So I get x is equal to, and I'll have to use my calculator for this. So I have the ln of 8,320 ln divided by, I'll put parentheses, 6 times 5, the ln of 5, I'll have to end the parenthesis and then hit enter. It gives me 0.935. So 0.935 is my approximate answer. On this next one, the first thing I want to do is I want to divide by 3 on both sides. Otherwise, I can't really use my ln properties, so I just get 86 over 3. Feel free to change that to a decimal if you'd like. Now I'll ln both sides. And then what I'm going to do is bring my exponent out front. So I have x minus 1. ln of 5 is equal to the ln of 86 over 3. I'll divide by ln of 5 on both sides. So I have ln of 86 over 3 divided by ln of 5. Now I'll get x by itself by adding 1 to both sides. Then I just need to push this in, or punch this in the calculator to figure out what it is, approximately 3 decimal places. So I am going to be punching in 86 divided by 3. I need the ln of that. Divided by 5. The ln of that is equal to this plus 1. So my answer is going to be 3.085. So 3.085 is my solution. One more review type problem before moving into derivatives. So this last one here, what we're going to be doing is we're going to say the base is 5, the exponent is 3.2, and then it equals the square root of x minus 4. So what we're going to do is we are going to say, well, I'm going to square both sides. So I'm going to have 5 to the 3.2 squared is equal to x minus 4. What I end up getting then is 5 to the 6.4 equals x minus 4. And then I can say that x is equal to 5 to the 6.4 plus 4. Then I can approximate that, and I'm not going to get out the calculator for this. You guys can do that, and then just check your answer with what I've written here. On the next problem, we are going to find the derivative, and so we need to look back at our notes as far as how to take a derivative on this. The derivative of an exponential part is just a to the x, the exponential part, and then you have the ln of a, and if it's anything other than an x, we have to take the derivative of it. So on this problem, we do have something other than an x, so we'll have to take the derivative of that part. So the derivative of this is equal to the ln of the a, the ln of the base, and then times the 3 to the 2x, and then we'll take the derivative of the exponent, which is times 2. Really, there's not a whole lot we can simplify. We can move that 2 out front. We could say this is 2 ln of 3. We can put some parentheses in here to hold things together so that you can see they're all multiplied together, but that's really all we can do. Going on, this one's very similar to it, except for we have a product rule here because we have a first times the derivative of the second, and we have 2 terms. So when I take the derivative of this, I end up getting first times the derivative of the second part, which would be the ln of 6 times 6 to the negative 2x times negative 2, plus the second times the derivative of the first, which happens to just be a 1. So when I simplify this, I end up getting negative 2x ln of 6, 6 to the negative 2x, plus 6 to the negative 2x. Now you could actually factor that part out if you wanted to, but there wouldn't be a whole lot else we could simplify. We have 2 more problems here. We're going to look at both of, this one again is a product rule, so I will say first times derivative of the second, which would be cosine of 2x times 2, plus the second times the derivative of the first, and this is the new part. So we have the ln of 5, and then we multiply it by 5 to the negative x over 2 times the derivative of that part, which is negative 1/2. So when I simplify this, it will end up looking like x to the negative 5 over 2, 2 cosine 2x, plus negative 1/2 sine of 2x, ln of 5, and 5 to the x minus, or x, negative x over 2. The last one is a log function, and we may want to go back to looking at the log. How do you take the derivative of a log? The derivative of a log is 1 over ln of a, and then with the part right here, u, and then you take the derivative of that part. So we're going to want to maybe use log properties in order to do this, because if we use the log properties, we'll have the log base 10, x squared minus 1, minus log base 10 of x. Now that makes it much easier to do this because we don't have to use a quotient rule. So I have 1 over the ln of 10, that's my base, and then I have the x squared minus 1, that's my u part, times the derivative of that, which is 2x, minus, I'd have 1 over the ln of 10, that's my ln of a, and then I have my u part, or my x. The derivative of x is 1, so that's finished. The only thing I really could do to simplify this is to factor out the ln of 10, which would give me this answer.